the lectures, and hopefully we can or you can get something out of the this second module 2 and session 3. So unlike Dr. Oreta's presentation, I cannot record it because I have to show uh, some tools from the website, so I have to do it live. That's why the ambient noise will once in a while uh, enter the scene. So anyway, my topic for this morning is on seismic hazard assessment, and hopefully after 30 minutes we'll be able to cover some parameters that you can use in assessing the generally assessing the seismic hazard at the site. And okay, so let me start with this phrase or paragraph from the Lord of the Rings. I wish it need not have happened in my time, said Frodo. So do I, said Gandalf. And so do all who live to see such times. But that is not for them to decide or for us to decide. What we can do now, all we have to do to decide is what to do with the time, that is given us. So you can see on the right side of your screen, uh, the hazards that we have experienced in the past years. So they always say, name it, we have it in the Philippines. And that makes our country like a big laboratory for hazard, not only seismic, but hazard assessments. And my colleagues in the DLSU are also members of ASEP, the Association of Structural Engineers of the Philippines. And especially when there's after an earthquake, we are engaged to visit those sites and see and learn from the damage, and hopefully we can update our code, update what we know, update our assessments. So we have been to Bohol, of course, Bohol earthquake, and the Porac earthquake, Surigao earthquake, and the destructive earthquakes in Makilala in 2019. So I think the main reason why we are here is we want to strengthen, or we want uh, to make sure, not make sure, but probably to prepare for any strong or extreme hazards that will in the future hit in any part of our country. So basically, this is what I'll do for this morning. I'll just give you a brief information of the damaged infrastructures. These pictures were taken during our visits and actual site visits and our meetings with, especially with our countrymen who experience especially strong earthquakes. And what we can do, or what information can we get related to seismic hazards? I think one of the most important thing that we can do right now, especially in our conservation management plan, the CMP, is to incorporate vulnerability aspects of the historical structure, or incorporate the hazards. I think that is what we can do in especially in the technical side. And then hopefully our administrators, our owners, stakeholders will see and will put that into the perspective of how we can slowly mitigate or prepare for these extreme events. Seismic parameters for hazard assessment, and online tools that are available that were developed by PHIVOLCS, specifically the fault finder and hazard hunter. These are indisposable tools that we can use to assess, maybe general level 1, as what Dr. Reta said, level 1 assessment. Just a snapshot of the strong magnitude earthquakes that has hit or have hit our country for the last 10, 20 years. And we really should be preparing for extreme earthquake events in the future. And especially that our heritage structures are vulnerable to extreme lateral shaking, extreme yes, seismic events. And you have seen there in recent years the earthquake in Porac. We visited one church that where the belfry, yeah, it fell down. And also in Makilala, the series of earthquakes in 2019. And some, although the earthquakes in Mindoro and Masbate were offshore, so there was not so much damage. But this continues, so this is not the end, and therefore we have to prepare for uh, for probably stronger earthquakes in the future. So these are some of not only to historical structures but as well as damage to schools. So we were able to document some schools that were damaged during as far as the 2013 Bohol earthquake and Surigao earthquake, the Leyte earthquake, and Batangas Warm 2017. Yeah, damage to hospitals, especially during the Bohol earthquake. And on the left side of your topmost of your screen was actually a very, it was recently, at the time, was constructed. And if I remember it right, if the Bohol earthquake did not happen, it should have been inaugurated after the on that after that day. But unfortunately, because of the strong ground motion, it failed, and therefore it has to be demolished and moved somewhere else because of there was a ground movement just behind the structure. So they had to put it in another place to reconstruct it. And some damage to infrastructures also during the Bohol earthquake. So yeah, not only historical structures, but as well as bridges, residential houses, even roads are can be vulnerable to earthquakes. And then the historical structures especially in this one is in Baclayon, Bohol. And see there a photo of us when we visited the site, and two major churches that collapsed entirely: the Loon Church and the Maribohok Church in Bohol after the earthquake. So it just collapsed in maybe a few minutes. And this is what I mentioned earlier in Santa Catalina, the Alejandria Church in Porac, and the belfry fell off, so it was vulnerable, as well as the Chuzon supermarket. Unfortunately, there were some people died during when the supermarket collapsed. And then after the Cotabato or the Makilala earthquakes, a lot of damage. Even the water distribution network also was damaged, and infrastructure, schools. So anything that was vulnerable sustained uh, either minor or moderate, or it was like total failure. So, what are the things that we can actually incorporate in our CNP, or in our or we can policies that we can incorporate into uh, related to historical structures? So we need this. We have information from our National Structural Code, the Philippines, the recent 2015. So we can then determine that either, for example, for Iloilo, that we are in zone 4. And when we say we are in zone 4, that means it's we expect strong earthquakes within this zone. And actually, in recent years, according to PHIVOLCS, they have seen that even as far as Tawi-Tawi, you can see that there's a lot of earthquake activities. And this zoning might be changed in the future. So for the meantime, this will hold for the zoning map for the Philippines. But as we have more data, especially from PHIVOLCS gather information, this might change. And so therefore we have to be prepared for it. So on the right side of your screen, you can see the just crop the area in Iloilo City, and you can see in the actually in the NSCP you can find this map, and you can see the active faults, and you are very near. Iloilo City is very near the West Panay Fault, and I think that's where the Kaikai earthquake happened so many years ago. So if it moves again, then we will our structures in Iloilo City will experience strong ground motion. In 2017, PHIVOLCS released the Philippine Earthquake Model, the PEM, and from here you can see the PGA or the peak growth acceleration map at the rock site for different return periods. In this case, you have the 500-year return period. And you have there in the contours the possible acceleration in G, and I just show in a bit of detail Iloilo City, and you can see there you have about a 0.4 G, and it's quite strong, and well it depends on how long the earthquake would be. There are still other factors, the period and so on. But this is an information that can help us prepare to protect or to mitigate any strong ground motion in the future. We also have the spectral acceleration maps of the Philippines. So this is the PEM was the precursor of the SAM-PH, and this was released just last month. And here you will now have the maximum considered earthquake, okay, or they call the 2475 return period earthquake. And PHIVOLCS use the probabilistic seismic hazard analysis, or the PSHA, to develop this spectral acceleration maps. And you can this is free, and you can download it, I think, in the PHIVOLCS website. And then you can see here on the right side of your screen the different earthquakes, fault lines, and that also that can have an effect, a major effect on the structures in Iloilo City. And okay, so these are information that we can use to be able to prepare for any strong ground motion in the future. And you also have the in the seismic hazard analysis, you need the information on the 1 second period of the earthquake, as well as the short period. That's why they also provided this, if you notice on the topmost of your screen, the 1 second spectral acceleration at 2,500 years MRI on the rock site. So meaning on the deeper layers of the soil, where there's the rock site, and the bearing stratum. And you can see there in your screen the different colors signifying the range of the acceleration. So we can use this information if you want to do something. For example, if you want to determine if the vulnerability of our structure, not only historical but as well as other structures. So some parameters for SHA, Seismic Hazard Assessment. In the NSCP, we have these tables that I'll show one at a time. And you can see here the zone, as I mentioned earlier, the zone seismic zone, point 2 and 2 and 4, and the factor, and the source type. The what is the maximum that moment that a fault can generate. These are estimates. So it's for example, for seismic source type A, it can probably generate 7 to 8.4, or seismic source type P from 6.5 to 7, and so on. So at least we can have some idea, but this information can also be researched more or gathered from also from PHIVOLCS. They have more data with respect to some faults that are near Iloilo City. And in this case, for example, this public market, and we have to determine what is the category, occupancy category. Is it considered an essential facility, or a hazardous facility, or a special occupancy structure, and so on. And there you have the importance factor. So basically, the importance factor increases the for example, the hazard, and therefore it can also mean that the impact on how you're going to retrofit it or design for it. So you have two seismic importance factor. And here you have some details on the category, as well as the occupancy or function of the structure. So it depends now if it's a church, if it's a historical church. In 2010, I think NSCP, there are some changes. No? So here we can already see churches in special occupancy structures, churches, mosques, and other religion facilities, or other buildings with occupant capacity and so on. So we can categorize or structure what type of occupancy, and then consider the importance factor. And we also want to know the distance of the structure with respect to a known fault, and because it is considered in the structural code by the near source factor. So how close is it? Is it within 2 kilometers, or 5 kilometers, or within 10 kilometers? Because there is a stronger effect, the stronger ground motion when the structure is near the fault. That's what has been observed. So therefore, we can also consider that the location. That's why the PHIVOLCS fault finder is an indispensable tool, because you can easily get, it shows you the distance, the shortest distance from your structure to the fault line. And yeah, near source factor, and NA and NV. And then some seismic coefficient A. Basically, these factors will be used to generate a design response spectra, okay, that will show you, inform us about the hazard at the site, in the building. One also important thing is that if we have information about the soil type, okay, as we know, as I've seen earlier, the peak ground acceleration or the spectral acceleration map shows you the bedrock, okay, in the rock site. So that means above that is the free field. So it depends now on the type of soil. So if the soil is relatively weak, then you will have some problems, especially in attenuation. Okay? So it will attenuate, it will strengthen or increase, amplify the bedrock acceleration. And the NSCP defines six soil types. So depending on the soil investigation of the site. So it's also important that we conduct soil investigation in the vicinity of our structure. Especially for new structures, this is required by the code. However, for existing structures, what we can do is probably get get information very near the structure, and we can infer that it will be the same soil type that's supporting the foundation. Okay, so from SA, which is a hard rock, the shear wave is about 1,500 to SF that requires site-specific evaluation. That means the soil type is not good. Okay, so SA to SF. So that means you need to conduct uh, more evaluation so that you can see if how this can possibly affect the structure, if especially if there's a strong ground motion. So either you can conduct a shear wave velocity test or by some borehole test, uh, just by getting the standard penetration test. So in the third column of the figure 2, table 28-2, you can see that the shear wave velocity, it can be conducted using a downhole shear wave test, or on the fourth column you have an SPT for just some geotechnical standard geotechnical boring tests. No? So it's either SPT or you can have shear wave velocity. This is an example of a boring lug, and on the left side, and you can see by layer, every 1 meter layer, the number of blows, or the SPT, the soil type, the soil description, the N value, the SPT N value, and normally we determine the first 30 meters of the because that's the liquefiable layer, the first 30 meters of the soil, and we estimate its soil type, to see if it is there is to see if it is SA or SB or SE, or it requires more site-specific evaluation. On the right side of your screen is an example of a shear wave velocity test results. And normally what we do is we compare these two. So in the same borehole, you have the SPT test and you have the shear wave velocity test, and you make some correlation. And in that correlation, more or less, you can give you some characterization of what is the shear wave velocity in some other parts of the soil. Although it's supposed to be very specific, but we can use that for nearby structures. So some example of the result of a geotechnical investigation. And using all of those information, that I've shown you earlier, then we can construct some kind of a design response spectra. Okay? And from here, the evaluator can use it to input into some model and determine what would be the demands on the specific elements, column, beams, and so on. And the top part of your screen is if you can get it from the NSCP using the parameters that I've shown earlier. Okay? So it's a general NS depending on the soil type. Here you have soil class T and soil class E. On the bottom side of your screen, this is from a site specific, we call it the site response analysis. And normally we have lots of boreholes within the area, and we also have shear wave velocity tests. And then based on those boreholes and shear wave velocity tests, we create a site-specific uh, response analysis. And this will be used by designers to assess or to design whatever structure is, especially for important structures that will be constructed on the site. But if we don't have that extensive data, we can use the NSCP parameters to be able to construct the spectra. So let me just see. Okay. So online tools, I will show this later on, and just to I will stop share and go to the website later on. This is for the PHIVOLCS fault finder. You can actually you can see or you can go to the site, and you can just type fault finder, and you can see this. You can click on this, and then gets you to the site like this one. Okay? So then you can choose. For in Manila, we have the valley fault system, or for other fault systems, you can just click it. And And using that fault finder, you can now see that the nearest or the shortest distance from the West Panay Fault is about 34.5 kilometers. Okay? So then you can use it for your uh, seismic hazard analysis. Okay? So you go to fault finder, you can input the coordinates and gives you the shortest distance. So now you're aware that your structure is very near or very far, or there's no fault around it, or yeah, something like that. And you can zoom in the bottom side of your screen, zoom into the point where you put the longitude and latitude. So you can see on the bottom side of your screen the estimated the longitude and latitude that you can input, and takes you to that point. And fault finder can estimate the distance, the nearest fault line. On the other hand, the PHIVOLCS Hazard Hunter not only is not only on seismic on fault line seismic hazard, but as well as other hazards. No? And same, you can Google it, and then it takes you to the Hazard Hunter site, and then you can type the coordinates of your structure, and gives you some kind of a report. And this is a snapshot of what if you input the longitude and latitude. So you can see on your screen here. I place the coordinates, estimate the coordinates, and gives me this map. Okay? So you can see that the distance, and not only the West Panay Fault, but also the nearest volcano, which is Canlaon volcano, about 69 kilometers. And if you click on this on the right side of your screen, this one, you can get a report, some recommendation, okay, about the hazards, okay? And so liquefaction, for example, tsunami, ground shaking, and so on. Okay, so as a summary, so that I have a few more minutes, 3 minutes before I end this presentation, so we can go to the website. As a summary, we can establish, in general, we can establish the seismic hazard parameters and hopefully put it in our management plan, and update it as we go along, because new information means new data means new information, and better inference. And we can use NSCP 2015 or the latest code, or if it is updated 2021 or 2022, we can use that. We can use the PEM, the Philippine Earthquake Model, or the SUMPH. So anything that is useful, or even survey from people who experience these earthquakes, can be helpful in determining the hazard at the site. And I've shown you some parameters using NSCP, and now I will show you the fault finder. And let me just quickly go to the site. There's your fault finder, and then if you type it, you go to the site, and you can click other fault system, and then you can there you go to, for example, Iloilo, and ano nga ba yung ano? What is the nearest Iloilo City there? Barangay. I've been on to Iloilo City quite a few times, so I'm not so familiar, but you can just click on sana nga ba yun? Just an example, ano? Ano ba yan? I was looking for it, but anyway, just click, for example, Yeah, something like this, huh? And yeah, Iloilo City is here. So depending on, yes, I think this is the one. Yeah, and then you can get the information how far it is from the earthquake. Di ko lang natama yung ano, yung ating here Rizal Street. So it should be here. Yeah. So somewhere here, it's about 40 kilometers from the nearest fault line. And then you can use that in your, especially in the deterministic seismic hazard analysis, we need the distance from the site to the fault line. So we can use that information. On the other hand, we can also use the hazard hunter, and here you can type the coordinates, you know, and that's my time. And the coordinates, for example, is if we type in longitude is about 122. Where is it? 122. 120. Longitude is 122, and the latitude is about 10. So and we can search, and then it takes us to the the site, no? And just a few more minutes, and give us some information, okay, about the structure. So see result. Okay, so here, so you can zoom in, and saan ba yun? Ayan, FINMA University. There's the public market, and we can see the on the right side of your screen the seismic hazard assessment. No? It's the nearest active fault is 34.4 kilometers, and he- here is 34 kilometers. Ground rupture is safe. Ground shaking is prone, and here, this one on the right side of your screen, seismic hazard assessment. Okay, liquefaction, it is highly susceptible. So I think we need some a detailed investigation of the soil. Uh, no information yet on the tsunami, and volcanic hazard assessment, hydrometeorological hazard assessment, and so on. And you also have the severe wind speeds from Pagasa. Okay. So all of this, since they are already available online, we can use that to update our CMP, or even our policies that can affect our policies, related to the preservation and of historical structures. And here we can click the report, view report with recommendation, and then gives you a report in PDF file. So yeah, I think that ends my presentation, and